Now we'll see the next step, that is the design of column. So I'll just first of all write step number 2, that is design of column. So here load is already given, that is 1600 kilonewton, and effective length is also given, that is 5 meter. So now the next step is to calculate the cross sectional area required, and we can assume the allowable compressive stress, that is allowable axial compressive stress, that is 150 MPa. So assume allowable axial compressive stress that is 150 MPa. Therefore now you can calculate, that is area is equal to load divided by stress. So area equals to P divided by sigma. So we have this P, that is 1600. We'll convert it in Newton and divide by stress, that is 150. So from this you will get what should be the cross-sectional area required for the calculation of the build-up column, and specifically if you are considering the channel sections, that might be I sections. In that case, for I sections you can also take the same step. So here area is coming out to be 10,667 mm square. So for this area we can just try any one of the ISMC section who's having the area, or you can say half of this 10,667. So you need to design it for the 2 I sections. So 2 I sections, so that is the reason area of both the I sections should be more than this 10,667 or near about the 10,667. So from the steel table, let us assume, or let us try ISMC 400. Since we have to design it channel sections, using channel section we have to design the build-up column. So we will just use this ISMC 400 at 489 kg, and you have to use in 2 in numbers as you have seen in the earlier diagrams. And what are the properties of it? So properties are already mentioned in the steel table. Area, so if you just make it double, so you will get more than this 10,667. Then you have this Rx 4.8 mm and Ry, that is 28.3 mm, and Tf you will get, that is 15.3 mm. So we can check what is the area provided by us. So area provided will be equals to 6293 multiplied by 2. So this is going to be 12586 mm square. Now we need to check the ratio of L by R so that we will get the design compressive strength required for this. If this design compressive strength is greater than the load factored load, in that case we can say whatever the assumed section of that is ISMC 400 with so that will be sufficient. So to calculate it, we need to go through the table number 9 on page number 42. So first of all, we need to calculate design compressive strength. So if we just look at this page number 42, we have this table number 9C, design compressive stress. So F5, we have this 250. We need to go through the KL by R ratio. So this KL by R ratio or L by R ratio we need to calculate, and accordingly we need to check this and this 250, whatever value we need to consider for the design compressive stress, and then we need to multiply it by the area. So therefore L by R, length is already given, that is 5 meter multiplied by 10 raised to the power 3. To make it in mm, R is, we have considered it from the 154.8. So if you calculate this, you will get it around, so we can make that it's like 33. So therefore, for, as I said, KL by R, which is equals to 33, and Fy, this is equals to 250 Newton per mm square. So for this, we can go before that we can just check the page number 44, that is table number 10. What exactly that table number 44 is all about. So table number 44 is this one, where we'll get this channel section or angle section. They are considered as buckling class C. So this is from the table number 10. So this is our table number 10, buckling class classification, and here in the last column we have this buckling class. So buckling class C, and that is the reason we have just checked. Now for this one, we have to check for the 30 as well as 40, and this is 250, so 211 and 198, in between this there will be our FCD value. We need to interpolate that. So you can write here from table number 9C, page number 42, we have this FCD. We will directly going through the interpolation part. So after interpolating, you will get it around 201 MPa. Now once you multiply it by the area, you will get the design compressive strength value. So therefore PD, this is design compressive strength, which is equals to FCD. FCD is 201, while AE, which we got area provided, that is 12586. and this is equals to 2529.78 kilonewton, and this is greater than PU, whatever factor load, that is 1600 kilonewton. So this is our second step, where we have calculated, first of all we have assumed what exactly the area is needed, and from that we have assumed one of the section, and from that section we have just calculated what is the design compressive strength, which should be greater than our factored load.